didn't really get into it. So example 3 here wanted us to find positive and negative intervals. And one of the hints I gave you guys is you use x values for these. And I wanted to add one other piece to this. You actually only ever use y values for range. That's the only time you ever care about y values. So if you just want to make yourself a little note here, I'm going to say only use y values for range. Every other interval, there's a lot of other types of intervals, use your x values. So for domain, you'll use your x values. For positive and negative intervals, you're going to use your x values. In just a minute, we're going to talk about increasing and decreasing. You're going to use x values for that as well. So basically, you only care about y values on your range and use x values for every other type of interval that you're going to look at. So in this example that we already did, we did when is this graph positive and when is it negative? So positive means when is it above the x-axis. So this had 2 positive sections, and we just wrote what those 2 intervals were. So from negative infinity to negative 3, this graph's positive, and from 3 on to infinity. So it had 2 positive intervals, and it had 1 negative. It was negative from negative 3 to 3. It can be hard to train your brain to read these correctly, but again, you only care about from what x to what x. So the fact that this goes down to like negative 9 is cool, but it has nothing to do with writing the intervals at all. The intervals are just from what x to what x. Is that graph positive or is that graph negative? So that's what we talked about to kind of finish things up on Friday. So let's pick up with now increasing and decreasing. This is different. Positive and negative is different from increasing and decreasing. Increasing means your graph is heading upward as you go from left to right. Decreasing is your graph is heading downward as you go from left to right. This graph was supposed to have been graphed on here, but it wasn't, so I'm just going to put it in there for you. Eventually, we're going to talk about how you know exactly what this is going to look like. We just aren't there yet. So this is an absolute value function, and it's at 2 minus. So the 2 actually means it starts up at 2. And then the negative absolute value function means it's going to be a downward-facing v. We're going to learn that stuff eventually. I actually wanted this to have already been graphed on here, but it's not. So just go down at a rate of, like a slope of negative 1. And then go down at I guess that'd be a positive one. But then also go down at a slope of negative 1 this way. So again, this graph should have already been on there. Not sure why it's not showing up, but pretend that was already there. So now let's read the question. So the question is, for what values of this function is it increasing? That's some weird, I think it's because I switched the document on this. But anyway, so the question is, when is this graph increasing and when is it decreasing? That's what we're going to try to answer. So increasing, you're looking for when does this graph have a positive slope? When is the graph heading upwards? So we always read graphs left to right. So it starts off, this graph is increasing. This graph is heading upward, 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 upward. And then here it stops and starts heading downward. So basically, this part of the graph is increasing. And this part of the graph would be considered decreasing. I'm just abbreviating, INC for increasing, DEC for decreasing. So at this point, all we need to do is just write those intervals. So over here, I'm going to say, okay, this graph is increasing from, and again, I talk about my x's. So from negative infinity until 0 is when this graph increases. So negative infinity to 0. And again, we say it doesn't include those values because at 0, the graph's not technically increasing or decreasing. It's stopped. It's like neutral. It's constant. And then we'd say this graph decreases from 0 on to positive infinity, because everywhere from here onward, the graph's heading downward. So 0 to positive infinity would be the decreasing interval. Any questions with those? So keep in mind, though, increasing, decreasing is not the same as positive and negative. Increasing and decreasing, we care about the slope. Is the graph heading upward or is the graph heading downward? Whereas in positive and negative, we care about where is it located. Is it above the x-axis? That's when it's positive, like those two. Or below is when it's negative. If you were to do the same question here, like let's just do it now because we can. Let's say we wanted to add in positive and negative intervals. So this question didn't ask for them, but let's say we wanted it to just add that in. When is this graph positive? This little small v part that's above here. So that would be from negative 2 to 2 is when this graph's positive. So we'd say from negative 2 to 2 is the times when this graph is positive, and it's got two negative sections. It's got one little negative section here, and then one little negative section here. So that'd be from negative infinity to negative 2. and 2 onto infinity. So again, I kind of want to do those both on the same graph just so you get an idea of they're not the same thing. Increasing and decreasing is different from positive and negative. Yep.
What about -2 to be
So the thing with these are, well, we really, with all 4 of these types of intervals, we actually never end up using brackets. And the rationale on that is at -2, like this graph isn't positive or negative, it's actually at 0. So in that case, this is the way I always remember it is, for all of these types of intervals, you will never use brackets. In fact, you'll only ever use brackets on domain and range. That's a good way to kind of, organize it in your head. Any other questions with these? Okay. Then we're going to talk this last example, which is example 5. So this is about average rate of change. This here talks about how you calculate rate of change using variables. I don't really want to answer this how it's asked, but I just want to talk about rate of change a little bit. So another word for rate of change that you guys are familiar with is slope. Okay, you've seen slope for years and years and years. Pre-algebra, algebra 1, probably even geometry a little bit. You've talked about slope before. So there's a couple ways to think about slope. One is rise over run. And another one is the just straight up slope formula, which is you're changing y over your change in x. So that one's usually written as like y2 minus y1 over x2 minus x1. Again, those are all a lot of just what I would call basic algebra concepts, but you want to be aware that that's how we're going to figure this out. So if we want to find the rate of change between 2 points, these are kind of the best routes to go. If it's graphed, just count rise and run. That's a super simple way to do it. If you have coordinates, use this formula. Plug the coordinates into this formula and be able to get the values that way. So what we're going to do, this is actually this example B. So like I said, I don't really want to answer what A did. I just want to kind of talk about it there. So B I want to talk about though. So B gives us 3 different graphs and also 3 different intervals. So this is actually 9 questions right here. Okay, but you're going to notice these are pretty quick to answer once you recognize what it's talking about. So let's just look at this graph first. Let's ignore the 2 that are on this side. And it says on each of these intervals that they give us down the line here, what is the rate of change over that interval? So like in this case, when they say from -2 to 0, again, these are x values. So from -2 to 0, they want to know what is the rate of change. So we go to the graph and we look at, okay, at -2, the graph's right here. And at 0, the graph's right here. And if I want to know what's the rate of change there, just think rise over run. As I go from this point to this point, there's no rise. So the rise is 0, and the run in this case is 2. So if you were doing your slope, which we use the letter M for, it'd be the rise of 2 over a run, rise of 0 over a run of 2, which is just 0. And actually, that should make sense if you remember how this works. A horizontal line has no slope. It has a slope of 0. It's not rising at all. And what you're going to notice with this is, because this stays a horizontal line, it doesn't even matter what interval you look at. Any interval you pick, so like this one says pick from 0 to 3. If you take the point that's at 0 to the point that's at 3, guess what? It doesn't change the rate of change. It's still a flat line, and therefore the slope or the rate of change is still just 0. Same logic. And even on this last interval, from -2 to 3, in this case, because this is just a flat line, the slope is always 0. There's no variance to this graph at all. It's always doing the same thing. It's always got a constant rate of change of 0. So then we move ahead to this next one. This is a linear function. This has like a y equals mx plus b type thing going on here. So the slope would be this 1/2. The y-intercept is the -1. So again, if you remember your algebra 1 stuff really well, you already know the slope. It's this number. But we can look at the intervals here just to double check this to make sure that what we know already makes sense. So they say on the interval from -2 to 0, what's going on here? So at -2, we're at this point. And at 0, we're at this point. If you count rise over run, it rises 1 unit and it runs 2 units. So it behaves exactly how we'd expect. The slope is a rise of 1, a run of 2. 1/2. Same thing as it says in the equation. Now for this problem, this is a constant line. It stays at that same rise of 1, run of 2, rise of 1, run of 2 forever. So no matter what interval you look at, you're going to get the same exact slope for this graph. Now that holds true with those first 2 examples. And that holds true for those first 2 examples because the 2 lines don't change at all. This line does the same thing forever. This line does the same thing forever. But now as you start getting into more complex lines, like this one, okay, this has that U shape. Name for that's a parabola. This does not have the same rate of change. In fact, it's got a different rate of change at every single point. So if you guys, most of you guys probably don't know a ton about calculus yet. You probably, maybe if you've ever heard little minor things, but calculus is based on the fact of finding the rate of change at a single point. Like at this exact point right here, what's the rate there versus at a point over here, what's the rate? And at a point here and at a point here and at every point, the rate is actually different because the slope is different. The line is steeper over here than it is right here. And that's what calculus is all about. So this is sort of like that little introduction piece to that, but this is pretty easy actually. So this wants us to say, okay, at this interval from -2 to 0, what's the rate of change? So at -2, we're at this point, and at 0, we're at 0. So if we count our rise, this has to go down 4. Again, pay attention to your scale here. We'd have to go down 4 and right 2. So for that, down 4 and right 2, we can simplify that. This one would have a slope of -2, which makes sense. As you're going from here to here, you're going down 2 units over 1, down 2 over 1 to get to there. But guess what? All our other intervals are not going to have that same slope because the graph's doing different things at those intervals. So the other interval was this from 0 to 3. So if we want to find what's this graph doing from 0 to 3, so at 0, it's here at 0. And then at 3, it's way up there at 9. So now this is going to now be a positive rate of change. We want to know what's this rate of change. Well, it's going up 9 and right 3. So that slope, up 9, right 3. Same process, reduce that. That's just going to be a slope of 3. And again, you're going to notice that because this line does all different things, you're going to have multiple different slopes depending on what interval you look at. Now the last one, this interval is kind of interesting. It sort of combines the two. So now it says, what about from the -2 to the 3? So now you start at -2, so you start at this point. Then you go to the 3, so you go to this point. So now you're looking at, like, what's this rate of change? Again, you notice it's going to be positive, but what does it do? So if we're up at 4 and we got to go up to 9, we're going up 5 and we're going over 5 because we're going from -2 to 3. So we just got to count there. So we're going up 5, right 5. So that slope, 5 over 5, is 1. And like I said, we should kind of expect to get all different answers there because the graph's doing different things on every one of those intervals. It's not just a constant line the whole way through there. So that's pretty much that.